Welcome to this video. Joining us. This video we're going to look at load and extension. Okay, load and extension. So in our previous video we talked about the force and the resultant what force. Okay, so we said force is simply a pull or push on an object, and it is measured using a spring balance. Okay, a spring balance. Okay, so let's look at load and extension. So suppose you have a spring that is hanging. So a spring is like this. Okay, so this is a spring. Okay, so now that is a spring there that is hanging. Okay, so at this point, as you can see, this spring, it has a length. Okay, so you measure the length of this spring from here up to there. Okay, so that is the length of the spring. Okay, or what we call the original length. Okay, that is the original length. Okay, so now a spring is able to extend and return back to its original position. Okay, so a spring can extend and then return back to its original position. Okay, so now let's say to this spring, suppose now we add, okay, we add a load. Okay, we add a load. Okay, so this is a load. Okay, so now you find that it is the exact same spring. Okay, it is the exact same spring. Here we just added a what? Added a load. We add a load. Okay, so now you find that the spring has done what? Extended. Okay, here the spring has done what? Extended. So we are going to put an extended spring. So the spring has extended. Now the original length was here. This is where the original length was for the spring. Okay, this is where the original length was. So what has been added? The spring has become longer. It has extended. So this added length here, okay, is what we call the extension. The added length is what we call the extension. Okay, the original spring is supposed to be so, meaning that what you have here now, the original length is this sign. So if you would measure the new length now up to here, we're going to call it length 1. Okay, that is the new length. Okay, which is the extended length. So you're going to say the length 1, which is the extended length, okay, minus the original length will give you the extension. Okay, will give you the extension. So in other words, let's say the length, the original here, was simply 5 centimeters. After it extended, it goes all the way to 12 centimeters. So you're going to say the extended spring from here up to here, it is what? 12 minus the original, which was 5. So meaning your extension will be what? Okay, our extension is simply 7 centimeters. Okay, so this was our extension. Okay, this was our extension. Now this spring, it is supposed to, when you remove this load, it's supposed to go back to its original state. Okay, if we would remove this load here, the spring should go back to its original state. Okay, it should go back to its what? Original state. Okay, and once the spring goes back to original state, we simply say that the string is what? Elastic. The spring, sorry, is elastic. Okay, so an elastic spring goes back to its original position, or let's say original length after being extended. Okay, after being extended, okay, it's supposed to go back to its original what? Length. Okay, it's supposed to go back to its original length. Okay, so now that is only load and what extension. So what happens is that if you have a spring, okay, you say this is your spring, okay, this is your spring without a load. You add the load, the spring gets extended, okay, and now you remove the load, the spring goes back to its original position. Okay, so it goes back to its original what? Position. Okay, so this is its L0, okay, original position, original length. So you added a load here, okay. Now here you remove the load, it still goes back to L0, okay. So this was L1, okay. So a spring without a load, this is its length. You add, it extends, okay. So this is the extension, okay. This is how much it extended. You remove the load, it goes back to its original position. Okay, so now what happens if, let's say, you get another spring, okay, you add the load on this spring, and then you add another load on this spring, it extends even more. Say here you added the 5 Newton, here you add 10 Newton. So find that from here the spring extends, okay, this is the extension. From here again it extends even more, extension 2, okay. So the spring has been extended from extension 1 to extension 2, okay. So now you find that at the end of the day this spring will go beyond the limit, elastic limit, okay. So the spring goes beyond what we call the elastic limit, okay. It's beyond elastic limit, okay. So meaning this spring, after you remove the load, you find that this spring, instead of going back to its original position, it remains extended, okay. So the spring fails to go back to original length. It fails to go back to its original what? Length, okay. So we say such a spring that fails to go back to its original length has exceeded elastic limit, okay. It has exceeded the elastic limit. So a spring that has exceeded the elastic limit cannot go back to its original position, cannot go back to its original position, okay. If it can go back to its original position, meaning it's still within the elastic limit, okay. So with that, let's look at what we call Hooke's law. So Hooke's law is a law that talks about loads and extension. The extension of the loaded spring is directly proportional to the load, okay. It's directly proportional to the load. So here let's deal with this spring, okay. So this spring, it has already a load, okay. Let's say the load here, it has the load, we call it load 1. So if a spring already contains a load, meaning that it already contains an extension, we're going to call this extension 1, okay. So now if you get the same spring, you change the load, okay, you change the load here. Now it is load 2. It will also going to contain an extension 2. It's going to extend again because it's extension 2. Okay, so according to Hooke's law, an extension of a loaded spring is directly proportional. So what are we saying? We're saying that extension of a loaded, okay, we started with the loaded spring. Extension of a loaded spring is directly proportional to the load, okay, directly proportional to the load. Okay, so this is going to be extension is equal to, we introduce k, which is the constant, okay. So to find this constant k, it's simply, we're going to say k is equal to, we divide both sides by L. So you get extension over load, okay, extension over load. So it extends by some constant, okay. So this formula can be written like this, okay. This simply means that extension 1 over load 1 must be equal to extension 2 over load 2, okay, extension 2 over load 2. Look at this example. So we have this spring, okay, without any load. So this is its original length. We're going to call it L0, okay. L0, that's the length, original length. So you have a load added here. So we're going to call this load as load 1. So the extension, how much it extended was 10 millimeters. So this is extension 1, okay. So you add another load here. We don't know how much load was added. We're going to call this load 2, and then this one is extension 2, okay. So we can calculate this missing load by using the formula we said, load 1, extension 1 over load 1 simply equal to extension 2 over load 2, okay. So extension 1, that is 10 over load 1, that is 4, is equal to extension 2, that is 15 over load 2. We're simply going to put load 2, cross multiply here. 10 times L2, that is going to be 10 L2 is equals to 4 times 15, okay. So 4 times 15. So you're going to multiply 4 times 15. Here we get what? 60 over 10 over 10. L2 is simply equal to what? 6. This is a load, so 6 newtons. The load is measured in what? In newtons, okay. So meaning here what was added is simply a 6 Newton load, okay, a 6 Newton load. I hope you've been able to learn something. You can watch the video, pause and watch it as many times as you can till you understand and get the concept behind load and extension.